We are now at section 8.4. Notice the title says z-test for a proportion, but notice we are still in chapter 8 that is talking about the hypothesis testing. It says many hypothesis testing situations involve proportions. And if you've kind of been seeing the overview of what we have done before, we did a z-test, a t-test, and then we did it for proportions. Well, we did 8.2 for the z-test when we knew the population standard deviation. 8.3 t-test, we didn't know the population standard deviation. Now we're at 8.4 and we can do the z-test for proportion. This is a great time, if you haven't already, to get out your notes, your notebook, paper, whatever you're going to do, highlighter, sticky notes, definitely a formula card. And so as I look at our formula card, and I'm in chapter 8, there's our z-test, our t-test, and now a z-test for proportions. And if you notice the pieces and parts, they all look familiar. We've just got to make sure that we identify them correctly, work on them correctly, and definitely get them in the calculator correctly. But then we've got to tie it all back into the whole process of the hypothesis testing. So don't forget, or do remember, that this table is inside of here, and that I've already asked you to write down the results that can happen on the table, which are, the results are on page 417, so you've already got them somewhere on here. One other thing is to remember that we do have table F, and at the bottom of table F, when we go to very large numbers, we end up getting these alphas that we're going to need depending on one tail or two tail. So it's all coming together, and at the very top it just mentions some data from odds, and they start throwing out these numbers, and especially all of the numbers that are getting thrown out during the pandemic. Where are they getting all of these numbers? 59% of this, or 32% of this, or they're getting them from multiple sources in multiple ways. However, a hypothesis test involving a population proportion can be considered binomial. We have seen that because there are only two outcomes, and the probability of success does not change from trial to trial. So the formula, I already mentioned and showed it to you on here for chapter 8, your z-test for proportions. You got to keep in mind when you get to the test, I'm going to try to help you out a little bit and say, hey, this is chapter 7 and this is chapter 8. But in chapter 8 they can be jumbled around, and how do I know when I need to pull out this one that's for proportions? Well, there are going to be some pieces and parts that are going to be screaming, use proportion. P hat is going to be this proportion from the sample. It may be given. We may have to go find it by taking the number that we're interested divided by the total number that are there. P is going to be the population proportion, and I wrote in Q. Q is 1 minus P. It gets a little confusing on the examples because sometimes what's going on in the ebook and what's going on in the book are different. I just want to point out a couple of places to be careful of. And then N is the sample size. Down here at the bottom, assumptions are going to be stated. I've already talked to you all about that, and you got to check to make sure that they've been met. But in our book, they're going to be met. They're going to take care of that for us. So you see I've got a whole lot of scribbly-do going on here, and then the first question is example 817, obese young people. So you and I are going to work through this one, but I want to go ahead and point out that I've got scribblies here, and then on page 447, at that example at the top, I've got scribblies there. The one at the top of 447 is actually the one that's incorrect. I scribbled out the wrong one, and I did it in pen. Not well done. But this one is correct, but there, you just got to be careful on the P's and Q's. Mind your P's and Q's. And your P's and Q's, because on this one, they used P hat here, and that is incorrect. Here, they use the actual P, which is the proportion from the problem, and that one is correct. But anyway, just to point those out, and then also to give you a heads up on what you're going to see when you're getting to the test. On our test, the hypothesis testing questions are going to be worth about 15 points each. So you need to know this process very well, and that you've practiced it without looking at your notes, and that you feel very comfortable with this. So let's practice again. A researcher claims that based on the information obtained from the Centers for Disease Control, we've heard the CDC a lot lately, 17% of people, young people 2 to 19, are obese. There's our population statistic. That is our proportion. To test this claim, she randomly selected 200, that's our N, and found that 42 of those were obese. Here's going to be our fraction, the X over the N. And at an alpha of 0.05, is there enough evidence to reject the claim? And so when you get your test, it's going to look, you're going to have a question, a statement, and then you're going to have these pieces and parts to complete. And that's it. And so we'll start with the hypothesis, and actually the hypotheses, because there will be 2 of them. And so I'm going to try to do a little of both here. And when you go to write these in, you need to write in clearly that you're talking about the null hypothesis, and in this case it is our P, and they're stating that it is 0.17. That one's null is always the equals. And then you need to do your alternative or alternate hypothesis, and they're saying that to test this claim, nope, what's her claim? She says a researcher based on the information that 17% are obese. Not less than 17, more than 17, they flat out are obese. And so she's saying the 0.17, again, that's our null. And so the alternative hypothesis, the alternate, is going to be, well, it's not greater than or less than, it's just, they're not this 0.17. So the claim is, she says that they are. So this one is our claim. She's saying they are obese, and the alternate to that is they're not. They're either less than that or they're more than that. And so then we're going to go look for critical values. And so looking here at the critical values, well, I don't think I've got a screen big enough to do this, but we'll try. Find the critical values, and our alpha is at 0.05. I just really like having a drawing. And my drawing is saying no matter what's going on, she is saying that whatever this acceptable piece is, she's saying that that's going to be our answer. They are this. And that's going to end up being our test region. We're going to have a number and a number. And, sorry, I'm scribbling in the wrong places. I'm trying to do way too much at one time. Ignore this piece in here, because our danger region is going to be the pieces out there. Our rejection region. Let's see if I can pause and erase that in the middle. So I got it erased. Just put some white on there. And I want us to go back to looking for our critical values. I like the picture because it is two-tailed. Since it is two-tailed and we're looking for a 0.05, I'm going to go to our chart. I'm surprised my little formula card has not fallen apart. It gets flipped around so much. And on our chart, the drawing clearly shows us that we have a two-tailed graph hypothesis test going on. We're looking at alpha for 0.05, two-tail 0.05. I'm going to go all the way down to the bottom of this column, and I'm looking at 1.960. But one of these has to be negative 1.960, and the other has to be positive 1.960. So this is something similar, pretty identical to what you're going to see on the test. You have to do the hypotheses, which one's the claim, and then find our critical value or values, and I like going ahead and putting them on the graph. And so we've got a bunch of stuff going on, and then it says, I'll just leave it right here. Compute the test value. First, it is necessary to find p hat. And so on here, it says find the test value. And when we looked at the formula a while ago on the other page, I'll go ahead and pull it up on our formula card. When we look at our formula card for Chapter 8, when we look at our z-test for proportion, we're going to need to know p hat P and Q and N. So let's play for just a second. P hat, actually I'm going to go for the easier ones first. P is the 0.17. Q is 1 minus 0.17, or 83 hundredths. And N would be the total amount in our sample. So looking here, I'm going to adjust, there we go, again a little bit better. Here's our N. 200 is our N. So that makes this part easy, that our N is 200, but we got to find P hat. P hat is our X over N. So we already know N is 200. Up here, we need to find out how many were in her sample. And her sample, well, how many were the X? 42 were found to be obese. 42 out of the sample size 200. From this, we can leave it as a fraction, we can turn it to a decimal, but either way we go, we can get all of this information into our formula. And so our formula is here, z equals p hat minus p. So z equals p hat minus p, all over square root of p times q over n, square root of p times q over n. So I'm going to fill in all of my pieces and parts, and like in the book, they went ahead and divided out. They went ahead and divided out the 42 divided by 200 and got 0.21. And then they have the P is this, and again, remember the one I scribbled out, this one is right, the P is 0.17 and this one's 0.83. But here, I'm just always leery of going ahead and dividing and rounding and rounding and rounding. But I will go ahead and divide out and get that 42 divided by 200 is a nice 0.21, or 21 hundredths. So here we go, filling in our blanks. Let me try to keep it where we can see it all. So I've got 21 hundredths minus 17 hundredths all over square root of that 17 hundredths. Let's go ahead and do 0.17 times 0.83, make my square root go a little further, all divided by our N is 200. We need to find our test value. That's what we're looking for. So we need an approximation. We don't need to spend a whole lot of time on this. And so if at all possible, I'm going to try to be smarter than my calculator, and I'm going to do this minus this and hit equals, and then I'm going to strike divide by. When I get my square root started, I'm going to do a parentheses and then my 0.17 times 0.83, and then close the parentheses, then divide by the 200 and hit equals. You got to know your calculator. Is one equals enough, or do you need to hit a second equals? So I'll go ahead and demonstrate this one. And in demonstrating this one, what I mentioned I was going to do is take my 0.21 minus my 0.17. And some of you may just love your parentheses and be a master of your, or mistress of your parentheses. But I just like to hit equals a whole bunch and try to outsmart the calculator. So I have the numerator in there, and I'm going to divide by. And when I tell it to do divide by the square root of, I'm going to open up another parentheses, because I wanted to take my 0.17 times my 0.83, close that parentheses, and divide off my 200, now close the square roots parentheses, and hit this. And so I'm getting a number of about 1.51-ish. That's good enough, 1.51-ish. I'll go double check with them, and they're getting about-ish, 1.51-ish. So you might want to hit pause here on the video, practice this, make sure you're punching very well. And when you're punching very well and you're comfortable to move on, then we get down to we need to make a decision. Are we in the no man's land, or are we okay? And then we can move on to that page and find out from our decision how we can write our conclusion. And so looking at our decision, we have our 1.51. And 1.51, if this is 0, 1.51-ish is going to land somewhere in here-ish. And so we are not in trouble. I don't know how you want to play around with this to find that we are not going to reject the null. We are safe, we are good, we are not in the forbidden land, whatever you want to call that. And so looking here at their words on make this decision, we are not going to reject the null hypothesis. But on the test, I'll say, what's your decision and why? And you will say, I or we are not going to reject the null because our value, our test value, did not fall in a rejection region, or our test value fell in a non-rejection region. Here, they say non-critical. So there are several words you can play around with, but get your words and practice those words from memory, since it falls in the non-critical. Yay! Or you could say it doesn't fall in the critical. But you need to tell me what you're doing. So we do not reject. We are not going to DNR, do not resuscitate, do not reject, and then give me a reason why we don't reject it. The last thing is the conclusion. We are not rejecting the null. We are not rejecting the null, and the claim was the null. It's now time to write a conclusion. We did not reject, and the claim was the null. So on your formula card, you have written down these pieces. And so we are not going to reject the null, and the claim is the null. So I'm going to cover up all the claims, the hypothesis, and the claim is the null. We're not going to reject, so we're going to have a sentence that says that there is not enough evidence to reject the claim, and this is where you got to fill in the rest. The claim that. And the claim that, let me go back and find where we were. And this is where you'll go up in the problem about what were we even trying to do. And they said, do not reject the null, not there, summarize. So on the test, there will be a part for your conclusion, and you will say something like, do not reject the null. No, I keep going to the wrong place. There is not enough evidence to reject the claim that. And then you'll fill in what the claim was. 17% of the young people ages 2 to 19 are obese. And then you're done. You have another video to watch, and then you'll be working example 818, I hope, all by yourself.